proportions. Proportions. I don't know if we have one. Do we? Proportional. Maybe we do.
We did at the beginning of it.
Perfect. Proportion. If you remember, we did proportions before, and proportions were nothing more than equal fractions. So you had something that looked like this. 1 over 5 would equal what number over 15? What would have to go above there if you're making equal fractions? We did this whole thing where we said, oh, 5 times 3 is 15, so 1 times 3 is, 3. Now, one thing you'll find out, and the whole gist of this section is, okay, what you must realize when you have equal fractions or proportions, you also have what we call equal cross products. And what that means in layman's 6th grade math terms is that when you multiply diagonals together, the diagonal numbers together, comma, they equal each other. Which won't make a lot of sense till we actually do that. When you multiply the diagonals, they equal each other. What that means is this. If I take these two numbers that are diagonal with each other, if I take 3, I'll get down here where it works, 3 times 5, that is 15. That will equal, if these are equal fractions or proportions, that will equal what the other two numbers multiplied together are, 15 times 1. And if the cross products are equal, then the things are what we call proportional and they're equal fractions. Now, how does that help? Well, ladies and gentlemen, if you see something like this, if you see 6 over 9 equals 10 over m. If you look at this, you can't go from 6 to 10. 6 times what is 10? I mean, maybe you can figure it out, maybe you can't. And when you can't do that, you can always use cross products, which means this. You know that these two diagonals, 6 times m, have to equal these two diagonals, 9 times 10. Well, 9 times 10 is 90. 6 times what number is 90? I might have to do that math. 90 divided by 6 is 15. So the letter m would be 15. M equals 15. It is also a quick way to tell if two fractions are equal to each other. For example, if you have 8 over 12 and 12 over 18, I know that those two fractions equal each other if when I multiply their diagonals, they are the same. 12 times 12, maybe you know, I don't know, it's 144. Is 8 times 18 144? 8 times 8 is 64, carry the 6. Yep. Since these diagonals both multiplied give me 144, I know that those are two equal fractions, which I would find out if I reduce them. What can you reduce this by?
4.
4 goes into both of those, you get 2/3. What can you reduce them by?
6.
6 goes into 12 twice, into 18, they both equal 2/3. But cross products is an easy way especially when you can't figure out what it is by doing equal fractions by multiplying top and bottom by same number, you can always use cross products. And sometimes your cross product doesn't work out very well. Sometimes it does. One more. What about 15 over 21 equals 7? 15 over 21 equals what number? Wait, yeah, over 70. Equals what number over 70? If you don't know, if you can't do the 21 times what is 70, because I don't know what 21 times 7 is 70, then you have to do the cross products. This times this, 21 times W has to equal 15 times 70. And sometimes it's going to require a little bit of work. What's 15 times 70? I don't know, we're going to do it here. 0, 5, 3, 1050. If I have 21, W equals 1050, how do I solve that? 21 times what number? Or do this, think of an easy problem. If I have 5 times 6 equals 30, if I don't know that this is a 6, what do I do by 30 to get 5 to get 6? Divide them out. 1050 divided by 21 equals 50. W equals 50 on top. So when the book asks you about cross products, or they ask you if something is proportional, you will easily be able to know what that is. It just means are the diagonals equal to each other. Now there's less than one. I thought that was exciting. Now, lesson number 2. Take out a blank piece of paper.